In this short demonstration, I'll show you how to use implicit differentiation using 3 separate examples. These are the steps. The first thing, you have to differentiate both sides, both the left and the right side, with respect to x. Second, you have to solve for the differentiated version of the y variable. Let me demonstrate. Question number 1 reads, differentiate x to the power of 2 plus y to the power of 2 is equal to 1. So we have to differentiate the left and the right side. Let's start with the left side. X to the power of 2 is 2x. Now since we are finding the derivative with respect to x, the derivative of y to the power of 2 becomes 2y using the power rule, and then you write down dy over dx. Now that's the left side. The derivative of 1 is equal to 0. The next thing you'll have to do is isolate for dy over dx. So we'll bring this term over, and it becomes negative 2x. And on the left side, we have 2y dy over dx. Now we'll divide both sides by 2y, which will isolate dy over dx. Negative 2x divided by positive 2y gives us negative x over y. And that's the answer. Let's move on to the next question. In this question, they're asking us to differentiate this equation. Once again, we'll start with the left side and then make our way over to the right side. On the left side, we have y to the power of 3, which becomes 3y to the power of 2 dy over dx. This becomes negative 4 because we're using the power rule. Bring this 2 down. 2 times 2 is 4. Y dy over dx. This becomes negative dy over dx. There's a 1 there. And that 2 goes to 0. That's the left side. And on the right side, what we have is 3x squared. Once again, we're using the power rule, plus 6x plus 2. Next, we'll factor out the dy over dx. dy over dx. 3y squared minus 4y minus 1 is equal to the right side. And we'll isolate for dy over dx by dividing both sides by this. And so that becomes your answer, and you can represent it as dy over dx, or you can represent it as y prime. In our final example, question 3, we are asked to differentiate x squared sine y is equal to y to the power of 3 minus e to the power of y. This looks like a candidate for the product rule, so keep that in mind. We'll start with that. We'll differentiate x to the power of 2, which is 2x, and we're going to leave sine y the way it is, plus we're going to leave this part the way it is, and differentiate sine y, which is equal to cosine y. And instead of using dy over dx, let's use y prime. On the right side, we're going to use the power rule for that first term, 3y squared y prime. This corresponds to that. And this becomes negative e to the power of y, which is the derivative of that term, y prime. Now let's gather all our y primes together. And if we do that, we end up with 3y squared y prime minus e to the power of y, y prime. We're going to bring this over, this whole term over, since it's connected. X squared cosine y, y prime. And on the left side, we have 2x sine y. And we need to isolate for this. So we're going to factor this out. And when we factor it out, we end up with 3y squared minus e to the power of y minus x squared cosine y. We're going to bring this over by dividing both sides by that. I'm going to skip a step here. Hope you forgive me for this. I'm going to bring this down here. And what I've done is I've simply divided both sides by this complicated expression, leaving us with the following. So there you have it. 3 solid examples on how to implicitly differentiate equations. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, you may visit our website at biology-forums.com. We are an online service for students seeking free homework help. See you soon.